Hello and welcome to my channel Learn with Simran. In this video, we are going to talk about different types of charts and when to use it and when not to use it. So let's not delay it further and get the learning started.
Let's start with a bar chart. A bar chart is a visual representation of categorical data using rectangular bars, where the length of each bar is proportional to the value it represents. Bar charts can be displayed either vertically, also known as column chart, or horizontally. Let's see when to use a bar chart. Bar charts are best used for comparing different categories, groups, or sets of data. They make it easy to see the difference or similarities at a glance. Now, what about discrete data? Use bar charts for discrete categories such as types of products, survey responses, or month of the year. Each bar represents a single category. These are ideal for showing the count, sum, or average of the items in each category, such as sales per region, votes per candidate, or website visits by month. While line charts are often better for showing trends over time, bar charts can be effective when the time intervals are not continuous or when you're looking at differences over specific periods. For example, sales by quarter. Let's see when not to use a bar chart. If there are too many categories, the chart may become cluttered and hard to read. In such cases, a pie chart, line chart, or a summarized visualization might be more appropriate. If the data represents a continuous range like temperature over time or stock prices, a line chart would be more suitable than a bar chart. For showing intricate patterns or trends over time, such as stock market performance or weather changes, a line chart or scatter plot is generally more effective. When you need to show proportions or percentages of a whole, for example, market share distribution, a pie chart might be a better option. To summarize, we can say bar charts are simple and versatile, making them one of the most common ways to present categorical data. However, choosing the right chart type depends on what kind of insight you want to convey. Bar charts come in various types, each serving different purposes depending on how you want to display and compare data. Here are the most common types. A vertical bar chart, also known as column chart, displays data using vertical bars where the height represents the value of each category. These are useful for comparing quantities across different categories. It is especially effective when labels for categories are short. Then comes horizontal bar chart. Similar to vertical bar chart, but the bars are horizontal. The length of each bar indicates the value of the category. Next comes stacked bar chart. Each bar is divided into sub-bars representing different parts of the whole. Each stack shows the breakdown of categories within a group. These are useful for showing the composition of categories and comparing totals across groups while simultaneously displaying subcategory contributions. Then comes a 100% stacked bar chart. This is a variation of the stacked bar chart where each bar represents 100% of the data and the segments within the bar show the proportion of subcategories. Are useful for comparing the relative percentage of subcategories across different groups. Next comes group or clustered bar chart. This displays multiple bars for each category group. Each group of bars represents a different category, and the bars within a group represent different subcategories. These are ideal for comparing subcategories within different groups. For example, comparing product sales across different regions and quarters. Next is our segmented bar chart. Similar to a stacked bar chart, but each segment has a defined separation within the bar to represent different data points. These are used when there is a need to display more distinct sections within each bar. Last in our bar section is bar line combination chart. This combines a bar chart with a line chart in a single graph. The bar represents one set of data, while the line represents another. These are useful for showing relationship between two different data sets, such as sales and profit margins. That's all for bar chart. Let's move on to another chart, line chart. A line chart is a type of chart used to visualize data points connected by straight lines. It is especially effective for showing trends over time or other continuous data. The horizontal axis represents a continuous variable such as time, while the vertical axis, y-axis, shows the values being measured. Individual data points are plotted and then connected by lines, illustrating changes in value across the y-axis. Line charts can display multiple lines to compare different data sets or categories on the same graph. Let's see when to use a line chart. These are ideal for displaying trends over periods, for example, days, months, years. Examples include stock prices, temperature changes, or sales over time. These are useful for representing continuous data where each point flows naturally into the next. These are great for highlighting trends such as growth, decline, or cycles to reveal insights about future predictions or patterns. When you want to compare changes across different categories, for example, sales of different products over a year, line charts can show these variations clearly. Now let's see when not to use a line chart. Not suited for comparing distinct unrelated categories, for example, different product sales without a time component. A bar chart would be more appropriate in this case. If you have too many lines, the chart can become cluttered and hard to interpret. In such cases, it may be better to use separate charts or a different type of visualization. Data points are random without any pattern, a line chart may not effectively communicate any insights. There are different types of line charts available like simple line chart or multiple line chart. There are also straight line chart and step line charts. We can summarize line charts as these are valuable for their simplicity and effectiveness in conveying time-based changes, trends, and patterns. That's all for line charts. Let's move on to area chart. Area chart is similar to line chart with the space between the line and the x-axis filled with color or shading. This added fill helps emphasize the magnitude of the values, giving a clear sense of volume. The x-axis typically represents a continuous variable, often time, while the y-axis displays the quantity or values. The space under the line is filled, highlighting the overall value at each point. It can display multiple data sets by stacking areas on top of one another, which can reveal the contribution of each category to the whole. It can display multiple data sets by stacking areas on top of one another, which can reveal the contribution of each category to the whole. Now let's see when to use an area chart. These are best used to visualize the size or volume of data over a continuous period. The filled area provides a sense of how values accumulate over time. Similar to line charts, area charts are effective for showing trends over time, especially when you want to emphasize the magnitude of changes. Stacked area charts are useful for comparing parts of a whole. They can show how individual components such as product sales contribute to the total overall revenue maybe over time. These are suitable for representing continuous data where each point flows into the next, such as stock market prices, cumulative sales, or weather patterns. Now let's see when not to use an area chart. If you have too many overlapping areas, the chart can become cluttered and hard to read. This makes it difficult to distinguish individual trends. When precise values or direct comparisons between categories are required, bar or line charts are more appropriate. The filled area can sometimes distort the perception of the actual value of each data point. Not suitable if the data does not represent accumulative totals. For example, showing individual data points without summing them would be better in a line chart. There are different types of area charts available like stacked area chart or 100% stacked area chart. We can summarize area charts as they are effective for showing trends, cumulative totals, and proportions over time, with the filled areas offering a visual representation of magnitude. However, care must be taken not to clutter the chart with too many layers. That's all for area chart. Now, a scatter plot is a type of data visualization used to show the relationship between two continuous variables. Each data point is represented as a dot on a Cartesian coordinate system. where the x-axis and the y-axis correspond to the values of two different variables. The x-axis and the y-axis represent two variables. Each data point's position is determined by its values on this axis. Each dot represents a single observation, with its horizontal and vertical positions indicated its values for two variables. A trend line to illustrate the overall pattern or correlation between the variables. Let's see when to use a scatter plot. Ideal for examining the correlation or relationship between two variables. For example, exploring the relationship between the height and weight, or advertising spend and sales revenue. These are useful for spotting trends, clusters, or outliers in the data. You can identify whether the variables have a positive correlation, negative, or no correlation. Scatter plots make it easy to identify data points that deviate significantly from the overall pattern, highlighting potential anomalies. When used with large data set, scatter plots can show the distribution and density of the data points across the graph space. Let's see when not to use a scatter plot. These are not suitable for categorical variables that don't have a numerical or continuous nature. Use a bar or pie chart instead for non-continuous data. If the dataset is extremely large, the scatter plot may become overcrowded, making it hard to read individual points. In such cases, consider using a density or scatter plots are not designed to show totals, averages, or distributions for categories. A box plot or histogram would be better for these purposes. There are different types of scatter plot are available like bubble scatter plot or 3D scatter plot or grouped scatter plot. A useful example for scatter plot in marketing is analyzing the relationship between advertising spend and sales revenue. Or example for health studies may include comparing variables such as age and blood pressure or weight and height. To summarize a scatter plot, we can say these are versatile tools for visualizing and exploring the relationship between two continuous variables. They make it easy to identify patterns, correlations, and outliers. However, this should be used carefully when dealing with large data sets or categorical variables. Moving on to the next chart, which is a heat map. It is a data visualization technique that uses color to represent the values of variables in a matrix or dataset. In heat maps, individual values contained in a matrix are represented by color coding, which makes it easy to identify patterns, correlations within complex datasets. See when to use a heat map. Understanding distribution and density, the very first point. Heat maps are effective for visualizing the distribution and density of data points across a matrix. For example, in a temperature map, you can see temperature variations across different geographical locations. Highlighting patterns, ideal for spotting trends, patterns, and correlations in large datasets. For example, you can use a heat map to find correlation between variables in correlation matrix. In categories, when you need to compare values across two categorical variables, for example, sales per product per region, heat map allowed for a quick and clear comparison. Visualizing complex data, suitable for visualizing large data sets where the other forms of charts like line or bar become too cluttered. This indicates website analytics, for example, click maps, customer segmentation, or real estate pricing. Let's see when not to use a heat map. Heat maps provide a general overview and are not ideal for showing precise numerical values. If you need to convey exact values, consider using tables or annotated graphs. When dealing with the small data sets, a heat map may not provide much value, and simpler visualization like bar or line might be more effective. Heat maps are designed to compare across two dimensions. If you are working with a single variable or need to show distribution over a single axis, other visualization like histogram might be more suitable. There are different types of heat maps available like matrix heat map or geographical heat map or correlation heat map, which you can use in data science projects or EDA or data analytics. Few examples of heat map use case may be website analytics. Click heat maps show where users click on a web page, revealing user behavior patterns, or in healthcare showing patient data such as heart rate or temperature variations over time. To summarize, we can say heat maps are powerful for visualizing complex data sets, allowing users to quickly identify patterns, correlations, and areas of interest using color gradients. However, they are best used for overview and pattern recognition. Moving on with our next chart, which is histogram plot. It is a type of bar chart used to visualize the distribution of a numerical dataset. It displays the frequency or count of data points within a specified ranges called bins. Unlike a bar chart that is used for categorical data, a histogram is specifically used for continuous numerical data. Let's see when to use a histogram. Histograms are ideal for visualizing the distribution of a dataset. They help identify the shape of the data distribution, such as normal or squared. Useful for finding patterns in data, such as a central tendency, spread, or outliers. They can show if the data is clustered around a specific value or is spread out across a range. These are effective when you want to count how many data points fall into specific ranges. For example, a histogram can show the frequency distribution of exam scores or age groups. These are helpful for summarizing characteristics of data such as mean, median, mode, or variance. Let's see when not to use a histogram. Histograms are meant for numerical data. For categorical data, use bar charts instead. If there are not enough data points, the histogram may not provide meaningful insights. In such cases, it might be better to use a different visualization. Using too many bins can make the data look noisy and difficult to interpret. Similarly, too few bins can oversimplify the data. To summarize, we can say histograms are a fundamental tool for visualizing the distribution and frequency of a numerical data. They provide insights into the central tendency, spread, and shape of the dataset, making them essential for EDA, exploratory data analysis. Proper bin selection and central labeling ensure the histogram effectively communicates the data story. Proper bin selection and careful labeling ensure the histogram effectively communicates the data story. Moving on, our next plot is distribution plot. A distribution plot is a statistical graph used to visualize the distribution of a dataset. It shows how values are distributed over a range and provide insights into the underlying characteristics of the data, such as central tendency, spread, and shape. Let's see when to use a distribution plot. Distribution plots are useful for visualizing the shape of the data distribution, identifying whether it is normal, squared, or any other shape. In the distributions of multiple datasets, distribution plots can highlight differences in central tendency, spread, and skewness. These are useful for spotting patterns in data, such as clustering, gaps, outliers, and the presence of multiple modes. Distribution plots are fundamental tools in EDA, providing insights into the statistical characteristics of a dataset, which means mean, median, variance, or skewness. Let's see when not to use a distribution plots. Distribution plots are designed for continuous numerical data. For categorical data, other visualizations like bar charts are more appropriate. With a very small dataset, a distribution plot might not provide meaningful insights, as it will have too many information to reveal patterns or distribution characteristics. If the goal is to display exact data values or counts in specific categories, use a histogram or a bar chart instead. To summarize distribution plot, we can say these are versatile tools for exploring and understanding the shape and characteristics of numerical data. They help identify patterns, clusters, skewness, and outliers, making them an essential part of exploratory data analysis. By choosing the appropriate plot like histogram, you can gain deeper insights into the underlying structure of your data. On with pie charts and donut charts. They both are circular graphs used to represent parts of a whole. They show how different categories contribute to a total by dividing the circle into slices or segments. While they are visually similar, there are some differences and specific use cases for each. Let's move ahead with pie chart. A pie chart is a full circle divided into slices, where each slice represents a category proportion of the whole. Each slice angle and size are proportional to the category's value relative to the total. Slices are typically labeled with percentages or values, indicate their contribution to the whole. Let's see when to use a pie chart and when not to. These are ideal for showing the proportion of a few categories to the whole. For example, market share among a few companies. Useful when comparing parts of a whole, especially when the number of categories is small and distinct. When you want to highlight how each part contributes to the total percentage, use pie chart. Let's see when not to use pie chart. These are not suitable for a large number of categories as the chart can become cluttered and difficult to interpret. Difficult to compare sizes accurately, especially if slices are close in size. Use a bar chart for more precise comparisons. These are ineffective for showing small differences between categories due to lack of precision in comparing slice sizes. Chart and talk about the feature first. A donut chart is similar to a pie chart but with a central hole, creating a donut shape. The hole can be used to display additional information or make the chart more visually appealing. Like a pie chart, it has segments or slices that represents parts of the whole, with the sizes proportional to their values. The central hole can be used to display total values, percentages, or additional information. When you want a more modern, aesthetical, pleasing version of a pie chart, the central hole can make the chart look cleaner and less cluttered. The central hole is useful for displaying the total value of the data or for adding context like showing a key figure or percentage. Like pie charts, donut charts are the best for showing the proportion of a small number of categories. Let's see when not to use a donut chart. Similar to pie charts, donut charts are not suitable for many categories as it can lead to visual clutter. Like pie charts, donut charts are not ideal for precise comparisons between similar sized segments. An example for pie chart. Market share distribution of different companies or budget allocation across departments or survey response breakdowns. Let's see an example for donut chart. Visualizing the same data as pie chart but with a random modern look, showing proportions with a central figure like total sales or population percentage. To summarize, we can say both pie and donut charts are useful for showing how different parts contribute to a whole, with donut charts offering a more modern look and space for additional information. However, they are best suited for simple data sets with a limited number of categories and are not ideal for precise comparisons or large amounts of data.
That's all for today's video. In this video, we have come across different terms like categorical data or continuous data. Let's dive more into the data in the next video. If you have liked the video, please follow and subscribe. Also, if you need this file for your reference, you can follow me on LinkedIn as I will be posting it on my profile. Thank you so much for watching. Keep learning. Bye bye.